Hi, I'm Mark from the uTasker project. Today I'd like to do some demonstrations of IPv6 operation on the Kinetis tower kits. For this demonstration I'll be using two tower kits. One tower kit has an F60F120 and the other one has an F70F120. Both boards are connected to Ethernet and they are situated behind an IPv4 router. The first thing to note is that the uTasker project has been loaded to both of the tower kits. So the first thing I'm going to do is to establish a connection to the first board on this IP address. Here we can see that we have a start page, we have various menu pages which can be browsed. The uTasker project has been compiled to use a dual stack. That means that we have IPv4 operation, as we see here, and we also have an IPv6 mode of operation. Now if I look in the LAN interface menu, we will see that we have two IPv6 addresses. We have a link local address, which is valid only on the local link, and we have a global IP address. Now the global IP address is unique in the global IPv6 network, which means that this device can be uniquely globally addressed from the internet. If we look at the image here, we see that we have a counter. Each time I update the web page, we get an increment, and it tells me which IPv4 address is being used to reach the page. So what I'll now do is open a second tab, and I will take the IP address on the link local. Now when you work with IPv6, you need to enter the IPv6 address in these square brackets, which means that now I can connect on the local link to the board. Now if we keep swapping the tabs, we'll see that when I browse using IPv4, it's counting the page serves and it's telling me that I'm connected on the IPv4 address. If I however use the IPv6 address, it's showing the link local IPv6 address of my PC, and it's also counting the amount of times the page has been served. I'm going to open another tab, and this time we're going to attempt to communicate with the board on its global IP address. So I'm going to take its global IP address and again put it in the URL entry box, and now we have a connection to the same tower kit, and this time it's running on this time it's connecting on its global IP address, and we can also see that the IPv6 address which is being used to contact the board is also the global IP address of this local PC. So now we can see we have connection to the web server on three different addresses: the IPv4 address, the link local address, and the global IPv6 address. Now we don't have to use just HTTP, we can also use, for example, Telnet. Here I have a Telnet window, and I'll be connecting on its global IPv6 address. Here we can see I can communicate using Telnet. I can also connect on the IPv4 address, which is also a local address, or I could connect on its link local address. Moving back to the web server, we can take a more detailed look at the operation using the global IPv6 address. First of all, we note that the actual image which is displayed is built up slightly slower because the connection is going out into the IPv6 internet and bouncing back to us, which is taking obviously longer than when it's using its local IPv4 address, or whether it's when it's using its link local IPv6 address. We can compare, you can see that it's served obviously a lot faster. Now, concentrating on the case of a global IPv6 connection, there's something very important which needs to be discussed. First of all, one needs to remember that the connection which I'm using is a simple IPv4 connection. My provider does not provide raw IPv6 services. Also, the router which I'm using for these tests is a simple, quite old IPv4 router. It has no idea about IPv6. The PC has been set up to do 6-in-4 tunneling, which means that the PC will try to use IPv6 by packing it into IPv4 data. When I now try to connect to this global IP address, what's actually happening is that the PC is tunneling the IPv6 data, sending it to a tunnel provider in the internet. The tunnel provider is now recognizing this global IPv4 address as belonging to a subnet in which my old IPv4 address is located. So it's actually bouncing it back to me. Now, my old router has no conception of the IPv4 tunnel data, so it doesn't actually know what to do with it. So what I've done is set up the router to send all unknown data to an IP address in the demilitarized zone, which is in fact the tower board, one of the tower boards. And what this tower board is doing is acting as a tunneling agent. It recognizes that it's receiving tunneled IPv4 data, and it has a small lookup table containing the IPv6 addresses which are in its local network, and it's then passing it onto the computer. So all of this traffic which we're seeing when we build up such a connection is actually passing through one of these tower kits. Otherwise it wouldn't work. I can show you that, because what I'll do now is turn off the board and we'll try again. Now what you can see here is that it's actually failing because the tower kit's been turned off. So I'm connecting the board again, and what we should then see is that the connection works again, which is what happens. Now I'm going to open up a new tab, and this time I'm going to browse to a well-known website. This is the website from the, I think it's pronounced Kamei or Kamai project. It's a Japanese word for turtle. Now, this project was one of the fundamental projects in IPv6 development, and I have this website with a turtle on it. Now, what happened in this case, I actually connected to the website using IPv4, and we can see the turtle is quite lifeless. So I'm going to actually connect directly to the IPv6 address of this website, which I know because I previously pinged it in IPv6 mode to make sure that I got the correct one. And now I've established a connection to it again. Now here we see that the turtle is dancing. The reason why the turtle is dancing is because the connection established to this website has been established over an IPv6 connection. Very similar to the MicroTasker start side, which also recognizes and displays the IP or the IPv4 or the IPv6 address of the source. Here again we have to note that this is only actually working across my connection due to the fact that the tower kit is acting as a relay agent and passing on all of the data back to the PC. One thing that you may be asking is, what is the actual practical significance of operating using IPv6? The interesting thing is that although we only have one IPv4 global address available to us, we now have the possibility of contacting two of these tower kits using globally unique IPv6 addresses. On the left hand side we have the original browser connection to the first of the tower kits. What I'm now going to do is I'm going to connect to the second tower board. Now the second tower board is also on the local network and has its own IP address. Here we can see that we're connected to the second board. Now note that we have a different ID name here so that we can see them easily. The other thing to note is that we also have a different IP address, of course. But what I'm going to do now is I'm going to connect to this board also on its globally unique IPv6 address. So what we have on the left hand side is the first tower kit connected on its globally unique IPv6 address. As we discussed before, this is a connection which is going out into the network, into the internet rather, and there we have the connection to the second board. Now the interesting thing is the first board is operating in the demilitarized zone, which means it's receiving the information from the internet and it can directly deliver the receptions to itself. In fact, in the case of the second tower kit, this is not in the demilitarized zone, which means that in fact all of the reception to it on its global IPv6 address, which is of course being tunneled in 6-in-1, is passing through the first tower kit and it's being relayed to it. So what we've just seen are two tower kits running a dual stack. Both of them have their own unique IPv6 global addresses, and both of these are contacted from the IPv6 internet, although they are situated via an IPv4 address. An important note about the two web servers which we saw in operation is that they are both operating on port 80. Although we have only a single IPv4 address, we can, using this relay technique, address theoretically many trillion IPv6 globally addressable servers behind this single IPv4 address. Before concluding, it's worth looking at a few more of the features which are in the MicroTasker project. We move to the administration page where we can see the cause of the last reset, how long the device has been operating for, and also how much stack and heap is remaining. If we want to upload new software to the board, we can choose the new software here, start the software execution, and there we saw that after about 2 seconds the new software was running. On the serial interface, we see that there are some AD values which are being periodically displayed. We also have a command line interface. The software is also monitoring the touch keys, and we can also see some messages when these are activated. We also have USB device connected, and we have a simple HID demonstration in operation. If you watch the mouse cursor here, I can control this by these keys in the up and down direction. We note also that the project code which we saw occupies around about 70 kilobytes of internal flash space and operates from about 30 kilobytes of RAM. The complete project was developed within the MicroTasker simulator environment. Here we see it running. Here we see the TWR-K K70F120 module being simulated. We have all of the touch sensors operating, we have the LEDs operating, we have the normal buttons operating. We also have the possibility to verify the way that all of the pins have been set up for correct operation. We can simulate USB. Here I simulate the enumeration of the device. And we also have real-time Ethernet operation. Many thanks for watching this video, and good luck with your own developments based on the Kinetis and MicroTasker.